Geometry students. Today's lesson will be on finding areas of sectors. And a sector is the part of a circle that is shaded in, like these shaded regions right here. Those would all be considered sectors of the circle. As you know, a circle has 360 degrees. We know how to find the area of the circle by using pi r squared. Now this is going to be very similar to the circumference and arc length sections where we took a percentage that the sector, that arc length was about 360 degrees. That was the percentage of the circumference. This is similar enough to the fact that we are finding the same percentage, but this time we're doing it of area instead of circumference. So if you got the last section, this should not be too difficult. As we look at this one right here, we have 90 degrees. So if the central angle is 90 degrees, we know that is 1/4 of the circle. Well, if we know the radius of the circle, we can find the area. If the radius is 7, then we know that 7 squared times pi. The area of that circle is then 49 pi. Since that sector is 1/4 of the circle, then I will take the area of the sector and just divide that by 4. Since that does not simplify, I can just say that the area of that sector is then 49 pi over 4. To look at another example, this sector is 45 degrees. The radius is 10. So if I'm going to find the area of this circle, I'm going to find the area of the circle, 10 times 10 times pi. That is 100 pi. 45 degrees. Well, if I don't know right off the bat what fraction that is of the circle, then I can come over here and I say 45 out of 360, and I just simplify that. So 45 out of 360, 45 times 2 is 90, 90 times 4 is 360, so I know this to be 1/8 of the circle. So that means that this sector is 1/8 of the area, which means that I can just divide that by 8. That divides by 4, that divides by 4. So therefore the area of that sector is 25 pi over 2. And you've got the area of that sector. To give you another example, this one right here, since all of this sector is 300 degrees, I would say that it is 300 out of 360 of the circle. Well, that reduced 30 over 36. That divides by 6, and that divides by 6. That sector is 5/6 of the circle. Since the radius is 6, 6 times 6 is 36, so that is 36 pi. Simplifying, I'm going to multiply the percentage of the circle, or the fraction of the circle, multiplied by the area. 36 over 6 reduces to 6 and 1. So therefore the area of that sector is 30 pi. Last example down here. On this page, we've got half the circle and then another 120 degrees. Well, I can think of this as that sector there is 60 degrees. Well, I just did this one over here. It was 5/6 of the circle. So I'm going to say that this is 5/6 of the circle. This time it gives us the diameter of 24. So therefore the radius would be 12. 12 squared is 144. So therefore I'm multiplying this by 144 pi, which is the area of the circle. I'm looking at 144 over 6 and 144 divided by 6, because I'm trying to simplify here in my head. 120 is 20, well, it would be 24 left over, so that would be 24. 24 times 5 is 90, actually it's not 90, 124 times 5 is 120 pi. So forget about that right there. So you've got your area. I don't know if you can see that on the screen. However, that would be 120 pi. As we go to a little bit of shaded regions, I'm going to erase and zoom up here a little bit. Get to the next section. Now would be a good time to fast forward. just a little bit. So let me step off. Oh no, shaded regions. Very similar to the ones that we did on the geometry page. If we're going to find this shaded region, what I'm going to do is I'm going to find the area of the sector and subtract the triangle off of it. All right, so 120 degrees out of 360 I know is 1/3 of the circle. So if I can find 1/3 of the area of the circle, and the circle is 4 pi, the radius is 2 times 2 times pi, the area is 4 pi, so this is 1/3 of the circle. So there is my area of that sector. I'm actually going to find now to the nearest tenth, so I'm going to grab my calculator. And 4 pi over 3 is 4 pi divided by 3. I'm just going to go to the nearest tenth, 4.2. All right, now to find the area of that triangle, remember that triangle formula where I had 1/2 the side length times the side length times the angle in between, the sine of that angle? That's the formula that I'm going to use right here. So area for triangle, area of triangle is going to be 1/2 A times B times the sine of the angle in between. So I'm going to use that here. So since this arc is 120, I know that this central angle is also 120. Since the radiuses are all 2, to find the area of that triangle, it would be 1/2 times 2 times 2 times the sine of 120. So I punch that in. Those are actually just going to cancel. So I have 2 times sine 120, and that is going to be 1.2. And that is the area of the triangle. So if I subtract these, I get 3.0, looks like it's in meters, and there is my area of the shaded region. Yay! To find the next one, number 14, again, we have a 90, we have a right angle, so therefore this is 1/4 of the circle. Radius is 10, so radius times pi. Area of the circle is 100 pi. I've got 1/4 of it, so therefore 25 pi, or 78 point something, 25 pi, 78.5. 78.5, there's your area of the sector. Again, I took 90 degrees, 1/4 of the circle. Since it has a radius of 10, 1/4 of the circle is 100 pi. Well, divided by 4 is 25 pi, which is 78.5. To find the area of the triangle, I know that the two radiuses are 10. Since it's a right triangle, I could use my triangle formula, base times height divided by 2. So 10 times 10 divided by 2 is 50. So if I just subtract 50 off this baby, 28.5 square centimeters, that is my area of the shaded region. And I did that by finding the area of the sector, subtract the triangle off of it. I'll do one more here. We have a very, very tiny sliver right here of shaded region. Ooh, nice drawing. Right there. Alrighty, so I know that this is a 60 degree, because it's vertical angles. So therefore, that is 1/6 of the circle. Well, if I have a radius of 8, that means that 64 pi is my area of the whole circle. I'll divide that by 6, because that is 1/6 of the circle. Well, I'll find out what that is. 64 pi divided by 6. That's 33.5. Looks right, 33.5 is my area of that sector. I'll subtract my triangle. In this case, I'll do 1/2 times 8 times 8 times the sine of 60. I realize that might be a little bit small, but I'm going to subtract the area of the triangle, and I'll use that triangle formula. So 1/2 times 8 times 8 times the sine of 60. So I'm going to do that now. So 64 divided by 2 times the sine of 60. match that up somehow. So 32 times the sine of 60. Why am I getting a negative number? Let me check hang with me. Oh, it's in radians. I need to switch it to degrees. I wonder about this one up here now. 64 divided by 2 times the sine of 60. There we go, 27. 27.7. So I'll subtract my area of the sector minus my triangle, minus 33.5, and I'm going to get 5.8 square inches, and that is my area of that little tiny sliver. Obviously, if I was going to do probability of the circle, I can do that divided by the whole circle, and I would have my probability. I'm just going to check my one up there real quick. 2 times the sine of 120. That one appears to be a little bit off. It was 1.7, but you get the general gist of how to find what these slivers are. So there is finding areas of sectors. Again, I'm going to upload this one today. It's Tuesday. The worksheet I will put on Classroom. They're also located in the front foyer of the Commons. If you don't have an internet access, then I really don't know how you're watching this, but you can always come up and get those worksheets there. Otherwise, some different ways that you can submit this stuff. I'm next going to talk about radians, but I know some of you have done the cons already. Good job. They're due tomorrow. Some people have the Google app on their phone. As far as mail, they take a picture of the assignment and then they can upload it or just email it to me. If you have questions, you can do it that way. You can submit questions through Classroom. Probably the best way is the email between 10 and 2 every day. I'll make sure that I'm around, that I can answer questions pretty quick. Outside of those hours, I'll still answer questions if I'm around, and most likely I don't have anything to do, so I'm pretty much here or stuck in my house all day. So I'll answer questions when I can. Other than that, we'll just kind of keep going. This does kind of wrap up this chapter. So towards the end of this week, I'm going to figure out how to kind of create a test, which might be the best way for you guys to take it. If you have any suggestions on anything that I could do better for you guys, please just let me know. Other than that, I will check in next time. Stay safe. Have a good day.